Section 5.4 deals with the other trig functions graphs. We're going to spend a lot less time on these other four functions: tangent, cotangent, cosecant, and secant, but I do want you to be aware of what they look like. Tangent and cotangent have a period of only 1 pi that differs from sine and cosine. They also have asymptotes on them. If we look at tangent, again, this is going to go around the unit circle, and it's going to graph the tangent, which is, remember, opposite over adjacent. As the triangle grows, the opposite side is getting bigger while the adjacent side is getting smaller. What's happening then is the tangent is getting bigger and bigger and bigger, and it actually approaches infinity. At 90 degrees, there is no tangent. It's undefined, so there's an asymptote there. You'd have division by 0. And then this just keeps repeating this low to high kind of wave. And notice those asymptotes being created. So one tangent wave is this right here. And notice that it's bound with these asymptotes on either side. So there's an asymptote at pi over 2, 3 pi over 2, and then it would keep going past this 5 over 2, 7 over 2, basically the odd pi over 2s, odd numerators. It also goes back the other way, negative pi over 2, negative 3 pi over 2, and again, it would keep going. And so the actual tangent graph, it looks kind of like cubic function, except cubic keeps expanding, this stays bounded. So I hug the asymptote, I'm going to hit at 0, and then I'm going to shoot up. And then basically I'm just going to keep repeating that. Now over here, I'm only going to see half just because I'm stopping my graph at 2 pi, but it would keep going. Over here, I'd only see the top half of one of them, but it just keeps cycling through like that. Cotangent, on the other hand, it's undefined at the even numerators of pi over 2, meaning 2 over 2, which is pi, 2 pi, 0, negative pi over 2, negative 2 pi. And where tangent was going uphill, cotangent is going to go downhill. But it's going to look just about the same. It's just flipped and moving downhill instead of uphill. So similar graphs, except shifted and going in the opposite direction. So again, tangent and cotangent have asymptotes. Tangent, the way we mathematically write its asymptotes, they are at pi over 2 plus n pi. That n is an integer, so plus 1 pi, plus 2 pi, plus 3 pi, etc. Cotangent is at pi's plus n pi's. So pi, 2 pi, 3 pi, 4 pi, etc. So on these first two, we're going to graph 2 periods of the function. So we don't really have amplitude and all that stuff, but we do have a stretch of 3, which really graphically, that's just going to make it look a little skinnier. It's going to have a vertical stretch. But this is the big deal. I'm going to shift over pi over 6. That means I'm going to shift this thing to the right, pi over 6. So what does that mean graphically? Well, I did have an asymptote at negative pi over 2. I'm just picking one of them to start with. That asymptote is going to get shifted to the right by a distance of pi over 6. So if I add pi over 6 to that, negative pi over 2 plus pi over 6, get common denominators, you'd have negative 2 pi over 6 or negative pi over 3. That means that all my other asymptotes are also going to shift. There's an asymptote at pi over 2. If I add pi over 6 to that, I'll get 2 pi over 3.